Ah, self-watering pots. You've seen them, maybe you even own one. For some people, they're an absolute miracle, a game changer that keeps their trickiest plants thriving. But for others, they are silent killers, turning gorgeous, healthy plants into a mushy, tragic mess. So, what's the real story here?
This is really the heart of the issue, right? You've got the incredible promise of a set-it-and-forget-it solution on one hand, and the grim reality of root rot on the other. So, is it a blessing, or is it a trap? Well, the truth is, it's both. And by the end of this explainer, you'll know exactly how to build the blessing and completely avoid the trap. Let's get into it.
Okay, so to really master these pots, we first have to get a handle on the physics of how they actually work. And step one is to get the name right. They aren't really self-watering at all. A much better name for them is sub-irrigation planters, or SIPs for short.
The whole magic trick behind these pots comes down to one scientific principle: capillary action. You've seen this a million times. Think about a paper towel soaking up a spill. See how the water just climbs right up the towel, totally defying gravity? That's happening because of two things: adhesion, which is the water sticking to the towel fibers, and cohesion, which is the water molecules sticking to each other and pulling their buddies along for the ride. In a self-watering pot, the exact same thing is happening, with water climbing from that reservoir all the way up through the soil to your plant's roots.
So why do so many pros absolutely love these things? Well, it boils down to three big reasons. First, you get soil homeostasis. That's just a fancy way of saying the soil stays perfectly, consistently moist. You avoid that stressful drought and flood cycle you get with regular watering. Second, nutrient retention. Because no water ever drains out the bottom, all that expensive fertilizer you add stays right there in the pot, feeding the plant instead of going down the drain. And third, fungal prevention. Watering from the bottom keeps the leaves perfectly dry, which is an absolute game changer for plants that are prone to nasty stuff like powdery mildew.
But, and this is a big but, there is a dark side. All those amazing benefits we just talked about, they can flip and become lethal flaws. The very thing that makes these pots work so well, that constant, steady access to water, is also what makes them so incredibly dangerous if you're not careful.
And here it is, the one thing most people completely forget about plants. Roots need to breathe. It's not just the leaves doing all the work. The roots need oxygen to convert sugars into energy to live. You see, healthy soil isn't just mud. It's a complex mix of solid particles, water, and, this is the crucial part, tiny pockets of air.
So here's the four-step journey to disaster when those air pockets disappear. First, the soil gets completely saturated. Water rushes in and pushes all the air out. Next, the roots enter a state of hypoxia. They are literally starving for oxygen. After that comes necrosis. The root tissue, unable to breathe, suffocates and dies. And finally, the pathogen attack. Bacteria and molds that just love wet, low-oxygen conditions show up for a feast on all that dead tissue. And that, my friends, is root rot.
But believe it or not, suffocation isn't the only threat. You also have to worry about salt buildup. Think about it. Water only ever leaves the pot by evaporating up. So where do all the minerals from your tap water and the leftover fertilizer salts go? Nowhere. They get left behind, building up month after month, until they're so concentrated they chemically burn the roots. This is exactly why you might see those confusing crispy brown leaf tips, even when the water reservoir is totally full.
So, what's the most important takeaway from all this? It's that success with these pots is like 90% about plant selection. It all comes down to matchmaking. You simply cannot fight millions of years of a plant's evolutionary history. You can't take a cactus that evolved to survive in a bone-dry desert and expect it to be happy living in what is essentially a man-made swamp.
All right, consider this chart your ultimate cheat sheet. Over on the left, you've got the thrivers. These are your water guzzlers, plants that come from consistently moist environments, like ferns, peace lilies, and most herbs. They are perfect candidates. In the middle, you have the survivors. These guys, like pothos and monsteras, can definitely work, but you have to be careful and follow the rules we're about to cover. And then you have the victims. Plants like succulents, snake plants, and ZZ plants have evolved to store their own water. Constant moisture will literally make their roots and cells rot from the inside out. Please avoid these pairings at all costs.
Okay, so you've picked the right plant. Great. Now what? Let's get into the real secrets, the stuff the manufacturers almost never put on the box. These are the key variables and the simple maintenance routines that will absolutely guarantee your success. This right here. This might be the single most important rule. If you remember only one thing from this entire explainer, please let it be this. Standard potting soil is typically made of fine particles like peat moss. In a self-watering pot, it acts like a dense, heavy sponge.
wicking up way too much water and holding onto it for dear life, creating that perfect, airless, muddy environment that's a breeding ground for root rot.
So what's the solution? It's something I call the aerated blend, and it's a super simple golden ratio. Mix your potting soil 50-50 with an aeration amendment, like perlite or pumice. You know, those little white rocks? What they do is create permanent air pockets throughout the soil that water just can't fill up. This is your insurance policy. It guarantees that even when the soil is perfectly damp, your plant's roots can always breathe.
Next up is the dry week rule. You know, the biggest mistake people make is they see the reservoirs empty and they immediately rush to top it off. Don't do it. You have to fight that urge. Instead, wait. Wait anywhere from 3 to 7 days after it's gone completely dry. This short drought period is amazing because it allows oxygen to penetrate deep into the root ball. And, as a little bonus, it helps kill off any annoying fungus gnat larvae that might be hanging out in that top layer of soil.
And to deal with that nasty salt buildup we talked about, you need to perform what I call a quarterly flush. It's easy. Every 3 months or so, just take your pot to the sink and water it heavily from the top, just like you would a regular plant. Let a ton of water run through it to flush out all those accumulated minerals, and then just dump out whatever is left in the reservoir. It's like hitting a reset button for your soil. All right, just a couple of quick pro tips to wrap things up. First, mosquitoes. That little pool of standing water in the reservoir can be a 5-star hotel for them, so make sure your pot's fill tube has a cap or just find a way to cover it yourself. And second, fertilizer. Remember, those nutrients are trapped in a closed system, so you should always use liquid fertilizer at quarter strength, or even better, switch to slow-release pellets that you mix into the soil. That'll help you avoid any chance of chemical burn.
So, after all of that, let's circle all the way back to our original question. Is the self-watering pot a blessing or a trap?
And here it is, the final verdict. The pot isn't the problem, and it's not the solution either. It's a tool. And just like any tool, whether it's useful or destructive depends entirely on the person using it. If you put a snake plant in dense, regular soil in one of these pots, congratulations, you've built a very effective root rot trap. But if you put a thirsty fern in that 50-50 aerated blend we talked about, you've created a blessing, a perfect, stable little microclimate where it's going to absolutely thrive.
See, the power isn't in the pot, it's in your understanding of the science. So now that you know the physics of water, soil, and roots, the only question left is, what are you going to build?